See?
Hello, this is Sean Moore, and I'm doing my presentation on JavaScript and its superset languages. So JavaScript began in 1995 when Brendan Eich created it as a web scripting language for Netscape. It was eventually named JavaScript for marketing reasons. So it was intended to be a lightweight complement to Java, and it was trademarked by Oracle. Eventually, in 1996, it was submitted to ECMA International for standardization. This standard was then titled ECMAScript to avoid trademark issues. Traditionally, JavaScript has been used for client-side scripting. However, recently with Node.js, it has been more prevalent with server-side scripting as well. JavaScript has a C-based syntax. For example, it uses curly braces to enclose functions and objects and semicolons to end statements. It is also case-sensitive. JavaScript is dynamically typed, so variables are not assigned a type when they're declared, but they can change type throughout the program. JavaScript is object-based, meaning that variables that are declared are actually objects. This includes functions as well. And objects are actually just associative arrays with key value pairs. JavaScript is prototype-based for its inheritance model. This means that objects inherit from other objects using prototypes, and there are no formal classes. Encapsulation in JavaScript is handled by closures, and there is no traditional access modifier like private, public, or protected. JavaScript has a very misleading name, and the C-based syntax have made it very easy to misuse the language. JavaScript has a lot more in common with Scheme and Lisp than other imperative languages. Object orientation, encapsulation, and inheritance are available in JavaScript, however they use non-traditional patterns. Traditional object-oriented programmers that use Java, C++, or C# are going to be more accustomed to the class-based model. Due to the lack of classes, type safety, and sometimes the syntax itself, other languages have been created to make it a lot easier to work with JavaScript. And these are the JavaScript superset languages like CoffeeScript, TypeScript, and Dart. The goal of CoffeeScript is to use the good parts of JavaScript in a simpler way. It does this using a lot of syntax sugar that simplifies the language for newer users. CoffeeScript syntax is very different from C-based languages and much more like Ruby or Python. The Coffee compiler translates, then compiles Coffee files to JS files. Semantically, CoffeeScript has a one-to-one relationship with JavaScript, so translation between CoffeeScript and JavaScript is very simple. CoffeeScript also ships directly with Ruby on Rails, making it very popular with Ruby developers. CoffeeScript syntax does not use semicolons to end statements, but instead uses new lines and indentation to separate blocks of code. Objects, conditionals, functions, and more can be created using new lines and indentations rather than curly braces, semicolons, and commas. The var JavaScript keyword for locally scoped variables is omitted and always applied when translated. Here are some examples of CoffeeScript. Functions use the assignment operator to separate the name of the function and the body of the function. Conditionals use the condition at the end of the statement rather than at the beginning. For loops are actually called comprehensions in CoffeeScript, and they use a for-in pattern for arrays and a for-of pattern for objects. You can actually embed JavaScript within CoffeeScript using backticks. So using a backtick at the beginning of your JavaScript and a backtick at the end, you can actually run that in the translator we'll leave it as it is. CoffeeScript has syntax sugar for basic class inheritance. However, underneath, it is still using the prototype-based inheritance model that JavaScript has. TypeScript is Microsoft's JavaScript superset language, which was developed by the lead architect of C#. The goal is to provide a strict JavaScript language with syntactic sugar that allows the simpler building of larger JavaScript applications. TypeScript ships directly with all versions of Visual Studio 2013 and greater. TypeScript was actually used to build AngularJS 2, JavaScript's framework that's built by Google. Syntactically, TypeScript is identical to JavaScript, which makes it really easy to use other JavaScript libraries within TypeScript. Semantically, it allows for static types, classes, interfaces, modules, generics, and other more advanced tools, but it still translates directly back to the prototype-based model that JavaScript has. Here is an example of some of the TypeScript features. It has optional static typing as well as type error checking. So if a type that you use is incorrect, the compiler will actually tell you. So here's an example of X being declared as a string. Interfaces allow for custom types. So you can define, in this case, a person interface, which must have a name string and an age that is a number. And then you can use that person interface within functions. And if the function parameter is not actually that interface, then you will receive an error. Functions themselves can even have interfaces, which allow you to define what the return type and the parameters should be. TypeScript classes are very similar to class-based implementations like C#, Java, and C++. And classes still cleanly translate to the prototype-based model. Dart is Google's JavaScript superset language. It was initially built to be embedded within Google's Chrome browser at some point. However, it was announced that this will not be happening. So it also translates to JavaScript and then compiles, like the other superset languages. Syntactically, it's C-based, but semantically, it is actually class-based and uses traditional inheritance. Dart uses its own class-based model, which is very different from the prototype-based JavaScript model, which means that it does not have as much flexibility with other JavaScript libraries. However, the advantage is that it's very similar to other class-based languages. So as you can see, this class example is very similar to other languages like Java, C++, or C#. In conclusion, CoffeeScript is still going to have a role with the Ruby and Python community, regardless of what happens with JavaScript. Semantically, it is very similar to JavaScript, but it provides syntax that is much more comfortable for that group of developers. When it comes to TypeScript and Dart, TypeScript has begun to fill the role that Dart attempted. It offers optional static typing and error checking, and it also provides a class-based inheritance model, even though it still translates down to a prototype-based architecture. Dart, on the other hand, is less flexible with other JavaScript libraries. It is also disheartening for the Dart community that AngularJS 2 was built using TypeScript and that Google decided not to embed it into its Chrome browser. However, even with all these changes, JavaScript itself is moving forward and starting to introduce more class-based features in future editions of ECMAScript. And because of these reasons, JavaScript is still the best option, in my opinion. However, TypeScript offers great features now that may eventually be included in JavaScript as well. Thank you for watching my presentation, and if there are any questions, please let me know.